Hello students, I have told you about the NEET question paper 2020 and today I am taking the NEET question paper 2019. Today I will take the question number 1 to 10. You watch the video completely and try to understand, to apply the concept, formula and the application. Question number 1 to 10. The paper series is P2. Now the first question is, in which of following process the heat is neither absorbed nor released? By a system. The options are: first, the isothermal; second, adiabatic; third is isobaric; and fourth, the isochoric. This is the direct question from the theoretical part. So you know that heat is neither absorbed nor released, that this takes place only in case of adiabatic process. So the right choice is adiabatic process. So the answer is your second. Question number 2. Increase in temperature of a gas. Increase in temperature of a gas filled in a container. Filled in a container. Would lead to: number 1, increase in mass; second, increase in its kinetic energy; in its kinetic energy; third, decrease in pressure; and fourth, Fourth is decrease in intermolecular distance. Molecular distance. When the temperature is increased, then you know that the motion of the particles increases. There may be increase in volume, there may be increase in pressure, but there is no increase in mass, no increase in the molecular distance, intermolecular distance. So this is the direct increase in its kinetic. So increase in kinetic energy means what? The particles of the system. So this is the only gas. So in case of gas, the kinetic energy there between kinetic energy of the molecules, there is no potential energy, and you have to assume that this gas is the ideal gas. So whenever temperature is increased, the kinetic energy of the system increases. So now right option is your second. Answer is second. Now question number 3. The energy of an electron, the total energy of an electron in an atom kinetic energy of an electron in an atom in an orbit is minus 3.4 electron volts. Its kinetic energy and potential energy are respectively option is first minus 3.4 electron volts and minus 3.4 electron volt. Second choice is minus 3.4 electron volt and minus 6.8 electron volts. Third option is 3.4 electron volts and minus 6.8 electron volt. Fourth is 3.4 electron volts and 3.4 electron volt. These are the options. We know that when the electron moves in the orbit around the nucleus, it has the kinetic energy, potential energy and the total energy. Total energy is always negative, potential energy is also negative, but kinetic energy is always positive. This is never negative. So first we are given the kinetic energy and then potential energy. So the first term which are negative, you have to eliminate them directly. So first option and second option you have to take it no account because the kinetic energy is given here the negative. Here the kinetic energy is positive, potential energy negative. Here the negative, this is now giving to positive and this is also giving the positive, but potential energy is never positive. So this option is also wrong, this option is wrong, this option is wrong. So we are having only this one, the third. So the correct choice is third. And also the potential energy is always double of the kinetic energy of the electron. So 2.4 double of it, so 3 is 6.8. This is being in negative, this is being in positive, so this is the right. Kinetic energy positive and potential energy negative. This is the right answer. And now question number 4. You are given the electrical circuit here. This is A, this is B, this is your 0, this is 1, this is 0, this is 1, and then here you are given a resistance R. This is plus 6 volt, and here we have then the resistance. This is also R. This is LED. And this part is earthed. The correct Boolean operation. The correct Boolean operation represented by the circuit diagram. The circuit diagram is now option is first is AND, second is OR, third is NAND, and fourth is NOR. Now if you see this circuit diagram, you will observe that if these two keys are off, the LED bulb will continue to light up because the current will pass directly through this circuit. If either of A and B is 0, even the LED bulb will glow. And if both are 1, both are to be 1, then the current will pass through this circuit. So no current will pass through LED. It means the LED will be off when A and B are 1 and 1. So this is what, if you want to find out this which gate is proper one, then just you prepare the truth table. This is solution A, B, 0, 0, then this is 1. We are getting to V1. Both are 0, the current will pass through this LED. This is now 1, 0, even this will be light up because current will again pass through this one. 0, 1, even the current will pass through this one. When it's 1 and 1, then this is equal to 0. So if you multiply these two terms, then you will find that this will be 0, this will be 0, this will be 0, this is 1, and you take the note, then this will be 1, 1, 1 and 0. If you add, suppose you add them, then this will be 0, this is 1, this is 1 and this is also 1. But these will not be the values which are given in according to this circuit. So this is not the this is not the NOR gate, not AND gate, not OR gate. So this is only the NAND gate. So our right answer is NAND gate. This is now third one. This is now right choice. This is the answer to the fourth question. And now fifth question. A block of mass 10 kg. Block of mass 10 kg is in contact with against inner wall of hollow cylinder. No, this is not cylinder but drum. Hollow drum. Hollow drum of radius 1 meter. Of radius 1 meter. The coefficient of friction between block and inner wall. Block and inner wall of cylinder is 0.1. The minimum angular velocity needed for cylinder to keep the block stationary when cylinder is vertical. Cylinder is vertical and rotating about the axis will be. Now options. Your first option is you are given the value of g to be 10 meter per second square. This is given. Now first option is square root of 10 radian per second. Second is 10 upon 2 pi radian per second. And third is 10 radian per second. And fourth is 10 pi radian per second. What is solution? This is the cylinder. It is being rotated about this axis, angular velocity omega. Here we have a block. This is block of 10 kg. So now its weight will act like this. This is mg. This is a reactional force R. The frictional force will act like this. This is Fl, frictional force. Now we have to find this angular velocity when this block remains stationary. It means that it does not move up and down. It remains at this point. Friction force equal to Fl, and this friction force must be less than this weight mg. It means that if this is less than to this one, then only that will happen here is that this will do not move upward. So what we have, this Fl less than the weight mg. Fl, this is now your mu r less than mg, and r will be what? This is being rotated, so it will have the centripetal acceleration, centripetal force. So R will be the centripetal force. Where R equal to reaction force or normal reaction. So this is equal to the centripetal force. Centripetal force. And this is mr omega square. So now you put this value. So this is now your mu r in place of r mr omega square equal to, this is now mg. Here this r is not equal to the weight of the body, as we tell you when it is taught in the theory, that when the body is placed on the surface, its weight acts vertically downward, but reaction force acts normally to this surface. In that case, the r is equal to the weight mg. But here, this r is always perpendicular to the surface on which the body is placed. So the body is in contact with this inner wall. So this will be perpendicular to this surface. Now this r will be now equal to the centripetal force. So this will cancel, and this omega equal to square root of g upon mu r, and this omega equal to square root, g is equal to 10, mu equal to 0.1, r equal to 1. Radius is given to be 1 meter. Radius 1 meter. So this, you remove this decimal, you keep it to be now 0. So this omega equal to 10 radian per second. So our right answer is what? That is your third one. Third answer. So this is what that we have the case when this is actually the application of your knowledge also, and the formula, and then you have to find out the value of angular velocity. This frictional force should be less than or equal to this weight mg. This is have to keep in mind that this r is not equal to mg. Normal reaction is not equal to mg, but normal reaction is equal to the centripetal force provided by this rotating cylinder. So this is the answer to the fifth question. And now I take the sixth question. Sixth question. Now sixth question is body A of mass 4m. Body A of mass 4m moving with speed u with the speed u collides with another body B the body B of mass 2m at rest. The collision is head-on elastic. Collision is head-on elastic in nature. After the collision, the fraction of energy lost by colliding body, lost by colliding body A is, now your options. First option is 1 by 9, second is 8 by 9, and third is your 4 by 9, and fifth is 5 by 9. 5 by 9. Solution. Now body A, so you are given this M1 equal to 4M, U1 equal to U, M2 equal to 2M, U2 is equal to 0, because second body is at rest. Collision is head on in nature. After the collision, the fraction of energy lost by the colliding body A. It means that you have to find the speed of the body A before collision and after collision. But before collision, this is given to you, the value is U. Then you have to find the speed after collision. So speed of body A after collision, V1, this we know, 2M2U2 plus M1 minus M2 into U1 upon M1 plus M2. This is a direct formula that you have to apply here. So this is what this 2M is, this is now your 2M into this is now 0 plus this is 4M minus 2M into U1, this is now your U upon, this is now your 4M plus 2M. Now this V1 equal to, this term is 0, this is now your 2mu upon, this is now your 6m. M and M will cancel, this will cancel by 3. So this is u by 3. So the velocity of the body A after the collision is u by 3. Now loss in energy. Loss in energy of body A, delta E upon E1. So this is E1 minus E2 upon, this is the loss. Loss, it means that the kinetic energy after the collision is less than the kinetic energy before collision. So this is equal to half M1 U1 square minus half M1 B1 square upon half M1 U1 square. This is before collision, this is after collision. So this is equal to this 1 by 2 M1 you take common, and this is now your U1 square minus B1 square upon 1 by 2 M1 U1 square. So 1 by 2 M1 U1 will cancel. U1 given to be now U, B1 is given to now U by 3 whole square upon, this is now your U square. So this is how much? U square minus U square by 9 upon U square. So this is now 8 by 9, and U square will cancel. This will cancel. So this is equal to 8 by 9. So now you see the right option is what? 8 by 9. Second one. So our right answer is second. So thus you see that first you have to find the velocity. Here the direct application of the formula, and then you find the loss in energy delta E upon E1. This is finding the fraction. This is given the fraction. So we have taken this divided by E1. If this not the fraction, then we have not to take this E1. Then we have directly find the value of delta E. Since there is loss of energy, so this is easily understandable that the initial energy is more than the final energy. So you have to find this E1 minus E2, and then you calculate, you will find the answer. This is the answer to the question number 6. And now question number 7. Question number 7. The speed of a swimmer in still water is 20 meter per second. 20 meter per second. The speed of river is 10 meter per second and is flowing due east and is flowing due east. If he is standing in south bank, on south bank, and wishes to cross the river along shortest route. The river along shortest route, shortest path, it is given now path, shortest path. The angle at which he should make, the angle at which he should make his strokes with respect to north, is given by. Now the options are here. First is your 30 degree east, second 30 degree west, second is 0 degree, third is 60 degree west, and fourth is 45 degree west. This is the question. Solution is what? First you write down the direction. This is east, west, north and south. So this is the river. This is the river. Flowing due east. This is the direction east. And when the still water means that this river is not moving, the water of the river is not moving, then this is the shortest route. This is the shortest route. He is standing here in the south direction. This is the observer A, and he want to cross this river in the shortest route. So this line perpendicular to the flow of this river, this is the shortest route. Now if suppose this goes in this direction, then he will not reach at this point, because he will go ahead. So he has not to move downstream, but he has to move upstream. This is the upstream, so he has to move like this one. He should move in this way. In this way. If this moves in this path, then it will make some angle. If this moves in this way, then it will reach at this point. So this is point the B, this is the point C. So when this is going in this way, then the speed is your 20 meter per second. This is given to 20 meter per second. So this is your 20 meter per second. 20 meter per second. And river is flowing in this way. It means that this is giving you 10. This is a right angle triangle. So you can have, this is the perpendicular, this is the hypotenuse. So you can have sin theta is equal to perpendicular upon hypotenuse 10 upon 20. This will cancel. This is 1 by 2. Sin theta equal to 1 by 2. So theta equal to 30 degree. It means that the swimmer has to move due west, like this one. This is east, this is west. So he has to move due west at an angle of 30 degree with the normal AB. So our right choice is 30 degree west. This is now first is the right answer. Always remember, then whenever the river is still, then whatever the speed is given to cross the river, that he has to follow with the same speed when the river water is moving. So this is the speed 20, and when it will reach at this must be downstream. So it must be in the upstream, not in the downstream. So in downstream he has to move from this point B. So just to reach at the point B, he has to make an angle 30 degree due west. So this is the right answer. Now question number 8. A mass n is attached. A mass n is attached to a thin wire and whirled in a vertical circle. In a vertical circle. The wire is most likely to break. The wire is most likely to break when option is number 1, mass is at highest point. Is at highest point. Second, the wire is horizontal. The wire is horizontal. Third, the mass is at lowest point. The mass is at lowest point. And fourth, inclined at an angle (60° from vertical. Now the solution to this question. This is a wire this is the highest point, this is the lowest point. It is being welded in this vertical circuit. This is being in the vertical circuit, so you first this omit this question, this option, this second is not at all. At an angle 60, this is also not at all. Since the this wire will break due to the tension in it, so we have to find the point where the tension is maximum. At the lowest point, the tension is minimum. At the highest point, tension is minimum, and at lowest point, the tension is maximum. You know that here the tension is 6 mg, 6 times the mass of the weight of the body. So this will likely to be break at this point B. The tension in wire is maximum at lowest point. It means that this will break at this point B. So our right answer is your B. This is now mass is at lowest point. The third option is correct. So this is the question number 8, and now question number 9. the displacement of a particle executing simple harmonic motion is given by y equal to a naught plus a sin omega t plus b cos omega t. Then amplitude of its oscillation. Then amplitude of its oscillation is given by the options are first a naught plus square root of a square plus b square, the second square root of a square plus b square, third square root a naught square plus a plus b whole square, and fourth a plus b. This is given. Now solution. You are given this y equal to a naught plus a sin omega t plus b cos omega t. Now this is given here. Now you see that this question is free from sin or cos terms. This is not the function of sin and cos, and these two terms are the function of sin, this is the function of cos. So this term is not included in the amplitude. The only terms, these two, will be taken into consideration, and you can know that this is being sin, this is being cos. The phase difference between these two is pi by 2. Phase difference between A and B equal to pi by 2 radian. So now you have like this, leave to this term A naught, leaving A naught, the amplitude equal to square root a square plus b square plus 2ab cos pi by 2. So this is only square root of a square plus b square. You have to leave to this one because this cos pi by 2 is equal to 0. So this means that these two particles are mutually perpendicular. So our right answer is what? Right answer is to this is not a square plus b square. The second, this is no right choice. And now question number 10. Question number 10. This is given a 800 turn coil. 800 turns coil. The effective area of 0.05 meter square is kept perpendicular to magnetic field magnetic field 5 into 10 raised to the power minus 5 Tesla. When the plane of coil is rotated, plane of coil is rotated by 90 degree. By 90 degree around any of its coplanar axis. Coplanar axis is rotated by 90 degree of its coplanar axis. The time is in time 0.1 second. The EMF induced in coil. The EMF induced is in coil will be, now option is first 2 volt, second 0.2 volt, third 2 into 10 raised to the power minus 3 volt, and fourth is 0.02 volt. How to find the solution? You apply the Faraday's law of electromagnetic induction. So induced EMF this is equal to minus delta phi upon delta t. So E is equal to minus, this is now your phi 2 minus phi 1 upon delta t. This is so much, and minus this is your NBA cos theta 2 minus NBA cos theta 1 upon delta t. So what we have, this minus NBA upon delta t cos theta 2. This is 90 degree. This is minus cos 0. So this E is equal to minus, now this will be 0, this is now minus 1, so this is now plus, so now plus NBA upon delta t. So now you put, this is now 800, B is 5 into 10 raised to the power minus 5, area 0.05 and delta t 0.1. So now by this point and this point, there will be 1 0 here, and this is 525 into 8. This is now 200, and 2 zeros are more, and this 1 0 will cancel from here. So we will have so much into 10 raised to the power minus 5. This is now 1, 2, 3, 4. 4 are here. So this we can write it to 0.02 volts. This is not right answer. This is not so much. So our correct answer is 4th, 0.02 volt. So this is what the answer to the question number 10. And this is direct application of the Faraday's laws of electromagnetic induction. Just you write down the value of this phi m, phi 2. And then this theta 1, theta 2, theta 1, theta 2 is 90 degree and theta 1 is equal to 0 degree, because first the coil is like this and then this is rotated by 90 degree like this. So it makes angle 90 degree in the final one, and initially it is 0. So now we are having this question. So this is what the answer of this question number 10. So students, all you like, share and subscribe the video, and also you watch the video completely, only then you can understand. I have told you this, I am repeating it again and again because this is only for your benefit. And select the short questions which are based upon your concept and the formula and the application knowledge. So thanks to all of you. Thank you very much.